All right, so this next section is on counting principles. So this is helpful for probability when you have a large number of objects that you're trying to count before you figure out the probability. So our first counting principle is the multiplication counting principle. And an example of this, because it's pretty complicated to understand in generic terms, an example is if you have 15 shirts and 4 pair of pants and you want to know how many different outfits you could make, you would have 15 times 4 or 60 different outfits. So if you're choosing one object from each group, you just multiply the number of objects in each group together to get the total number of options. A factorial is a symbol that I'm not sure if you guys have seen before. It looks like an exclamation point, so it's this symbol right here. And what it means is that you multiply all of the numbers, all the integers, less than or equal to that number till you get to 1. So 5 factorial, as you can see, is 5 times 4 times 3 times 2 times 1, or 120. I usually don't show the multiplication by 1 because that doesn't change anything, but technically a factorial is multiplying everything down to 1. So I wanted to be specific with the first example at least. And the main topic of our lesson today is going to be permutations. And so for example, if you are finishing a race, finishing first place is very different than finishing 4th place. So the order in which... All right, so the first thing that I want to do is look at where this multiplication counting principle comes from. So we're looking at building a sandwich, and we have a couple of different options of bread. We can have wheat bread or rye bread. So what I'm going to do is create a tree diagram to show the different sandwiches we could put together. After we choose our bread, we choose our meat. So I could choose wheat bread and then turkey, or wheat bread and then ham, or wheat bread and then chicken. Same goes with, I have the same options if I had chosen rye bread. And then lastly, we have 2 different kinds of cheese, cheddar or American. So I can choose wheat bread and turkey and then cheddar cheese or American. So I have that option with each of the different meats as well. So what ends up happening once we finish our tree diagram is that the options are all shown on the end here with the cheese. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different options. And that came from 2 options for bread times, and as you can see it expand with our meat options, the 3 different options we had for meat times the 2 different options that we had for cheese. And that gives us 2 times 3 is 6 times 2 is 12. So obviously the more options you have, the more cumbersome the tree diagram gets. Our tree diagram is pretty big with just a couple of different options in each category. All right, the next thing we're going to look at is getting into factorials. So we have 8 people racing. How many different ways can they finish? Well, as they're racing, there are 8 players who have an option of finishing first place. Once someone crosses the finish line, there are 7 people left for second place. And this is from the multiplication counting principle where we're multiplying our different options together. Once 2 people cross the finish line, we have 6 people left that could finish third, and 5 people for 4th, 4 people for 5th, 3 people for 6th place, 2 people for 7th place, and finally 1 person to finish last place. So when we multiply all of those options together, actually before we do that, we can condense that. This is 8 factorial. That's the definition of a factorial, is multiplying all of your options down to 1. And so if you're curious, it would be 40,320 different ways for 8 players to finish a race. All right, so now we're getting into permutations. How many ways can you elect a president, vice president, secretary, and treasurer from a list of 8 candidates? So we start this off similarly to the way that we started off our racers finishing. there are 8 people to choose from when you elect a president. And the person who's president can't also be vice president, so there are 7 people left to elect a vice president, and 6 people left to choose a secretary, and 5 people left to choose a treasurer. So we end up with 1,680 different options. But there's a formula for permutations. What ends up happening is we take 8 factorial, and that's all of the options to choose from, but we divide it by the number that we're choosing. So we're choosing 4, so we do 8 minus 4 factorial. And that ends up, if we expand this, we get 8 factorial. 8 minus 4 is 4 factorial. So if I wrote this all out, sorry, that should be a 7. Get rid of that real quick. Over the 4 factorial would be 4 times 3 times 2 times 1, and those would all cancel with the numbers in the numerator, and we would be left with what we were looking at over here. So the official formula for permutations, this is the number of objects you're choosing from. So in our example, we were choosing from 8 people. And the R is the number you are choosing, and we chose 4. So you can see an example of this formula. We were choosing 8 people, from 8 people, and we were electing 4 of them to positions. The last thing I want to do is just take a look at expanding this formula. How many permutations of 5 objects chosen from 12? So we start with 12 objects we're choosing from. It's a permutation, and we want to choose 5 of the objects. So the first number that we're choosing from goes in the numerator, factorial, over, and then we subtract the 2, 12 minus 5 factorial in the denominator. So we can expand that, or simplify our subtraction. And what ends up happening, again, when we expand, is that everything less than the number in the denominator, 7 factorial, will cancel with the 7 factorial. And so that would give us a total of 95,040.